Lesson 10-5 is on the Pythagorean Theorem. You're probably familiar with a right triangle, but let's go over some of the basics. A right triangle has a right angle in it, and the longest side of the triangle is called the hypotenuse. It's the side that is directly opposite the right angle. And then the other two sides are called the legs. In this case, I've used the letters A and B to designate the lengths of the legs, and the letter C to designate the length of the hypotenuse. The Pythagorean theorem says that the sum of the squares of the lengths of the legs of a right triangle is equal to the square of the length of the hypotenuse. That is, if you take the length of one leg and square it, take the length of the other leg and square it, and add those two together, that will be equal to the length of the hypotenuse squared. And I see I forgot to put a squared there. So in other words, if A and B are the legs, A squared plus B squared equals C squared, and C is always the hypotenuse. C must be the hypotenuse. You can interchange A and B, but C has to be the hypotenuse, and it's always the longest side of the triangle. So here are a few examples. Find each missing length and round to the nearest hundredth. So in this case, my two legs are designated by the lengths 8 and 12, and it really doesn't matter which one is A and which one is B. So I'm going to say 8 squared plus 12 squared is going to equal the length of the hypotenuse squared, and the hypotenuse is C. So now we just solve this for C. 64 plus 144 is equal to C squared, or 208 equals C squared. To undo the squaring of C, I'm going to take the square root of both sides, and the square root of something squared gives me just what's underneath there, C. So C is equal to the square root of 208, and if you pull out your calculator, I believe I said round to the nearest hundredth, that's approximately equal to 14.42. Here's another example. We have a triangle where one leg is 4. The other leg we don't know, but we do know that the hypotenuse is 21. So I'm going to say 4 squared plus B squared equals 21 squared. And now I need to solve this for B. 4 squared is 16. I don't know what B squared is. 21 squared is 441. Subtracting 16 from both sides, B squared is 425. And then we take the square root of both sides. Oops. So B is equal to the square root of 425, which is approximately equal to 20.62. Now the converse, or the opposite of the Pythagorean theorem, says that if the square of the length of the longest side of a triangle is equal to the sum of the squares of the lengths of the other two sides, then the triangle is a right triangle. In other words, if the square of the hypotenuse, or if the square of the longest side is equal to the other two sides squared and added together, then you know it is a right triangle. In the Pythagorean theorem, we were starting with the fact that the triangle is a right triangle, and then showing that the length of the hypotenuse is related to the length of the legs. In this case, we don't know it's a right triangle, but if the sides fit in the Pythagorean theorem, then it is a right triangle. A Pythagorean triple is a set of 3 natural numbers. That is, there's no decimals, no fractions, no square roots, no negatives, no zeros, that satisfy the Pythagorean theorem. In other words, 3 counting numbers that work in the Pythagorean theorem. Probably the most famous Pythagorean triple is 3, 4, 5. If you have a triangle that has one leg, that's 3, and the other leg, that's 4, and the third side is 5, you know that that is a right triangle. And if you don't believe me, you can try out the numbers. So here's a couple examples. Determine whether each set of measures can be the lengths of the sides of a right triangle. In other words, do these numbers work in the Pythagorean theorem? Then determine whether or not they form a Pythagorean triple. So let's plug these into the Pythagorean theorem. It doesn't matter which one's A or B, but the longest one has to be C. So I'm going to say 28 squared plus 45 squared, is that equal to 53 squared? Do they work in the Pythagorean theorem? 28 squared is 784. 45 squared is 2025. Is that equal to 53 squared, which is 2809? And when I add the first two numbers, yes, they do add up to 2809. So, yes, this is a right triangle. So it does work in the Pythagorean theorem, and because the numbers are natural numbers, that is, remember, no decimals, no fractions, no square roots, no negatives, no zeros, it is a Pythagorean triple. Here's another example. So does this work in the Pythagorean theorem? And remember, I can pick either one of the shorter ones to be A and B, and the longest one has to be C, the hypotenuse. So is 8 squared, which is 64, plus 31.5 squared, which is 992.25, is that equal to 32.5 squared, which is 1056.25? Is that actually true? And when I add these two numbers, indeed it is. So these are equal to each other. This does work in the Pythagorean theorem. So yes, it is a right triangle. So now the question is this a Pythagorean triple? And actually it is not. Not a Pythagorean triple, because the original numbers I had, the lengths of the sides, are decimals. And that's because we have decimals in our original numbers. Those are not counting numbers. Those are not natural numbers. And my last example, 4 and the square root of 26 and 12. Now, they're not always going to be lined up, so you need, in order from the shortest to the longest lengths of the sides of a triangle. So you have to kind of get an idea of which one of these is going to be the longest. And the square root of 26, I don't know off the top of my head, but I do know that the square root of 25 is equal to 5. So the square root of 26 is probably just a little bit bigger than 5. Okay, so this is 4, this is a little bit more than 5, and 12, of course, is going to be the largest number. So is 4 squared plus the square root of 26 squared equal to 12 squared? Is 16 plus 26, remember when you square a square root, it becomes just the radicand. Is that equal to 144? Clearly it is not. That's 42, and that is not equal to 144. So therefore it is not a right triangle. And if it's not a right triangle, it can't be a Pythagorean triple, but also we have a radical in there, so it can't be a Pythagorean triple for that reason also.